My name is Buck Woody. I am an applied data scientist here at Microsoft, and so I tend to work a lot with our clients on applying the artificial intelligence constructs that and platforms that we work with. I'm joined by my good friend Andrew Marshall. You can see his smiling face there as well. He'll be chiming in on the second part of this presentation. We've sort of split this up. We'll do a few minutes here on setting an overview for you. And then Andrew's going to come in and put a fine point on it. And then I'll join back in, turn my camera back on at the very end here so that we can take us out. Now, you're going to ask right away, one of the main questions that's always asked, hey, can I get those materials? I'm going to show you a lot of resources. And we're going to move quickly. We're not going to be rushed, but we're going to move quickly through the process. And you'll want to know, hey, where's that and where's this? There's a lot of information here, and we are going to give you that resource at the very end. So you need to stick around until Andrew is done regaling us with his topic there. Let's jump in on designing secure applications for artificial intelligence. Now, let me start off by saying there is the idea of using artificial intelligence for security, doing heuristic searching and predictive analytics and anomaly detection and so on. That's not what we're talking about here. We're actually talking about the other way around. We're talking about how do you secure artificial intelligence programs. The reason we bring this up is back in the good old days, just a few years ago, data scientists were often sort of a single seat kind of person. They knew statistics and programming and big data platforms, and they were able to combine all those things to do predictive and categorical type predictions. And then along came deep learning and other things. Well, as they grew bigger, the teams came into play. And so we at Microsoft were involved in lots of these early artificial intelligence programs going way back. And we came up with the idea that we needed to define a process, a team data science process. Now you can see there's a link down at the bottom for the TDSP. Let me just pop over and show you. It's literally got everything, including who does what and how they do it. There's a full set of documentation around every step, how you do it, the goals, the objectives. We've even got artifacts for you. So if you want to document your data sources, we've got a way to do that, and so on. So again, you'll get those links there at the end. But the team data science process basically breaks down into just a few phases. Now, all computer processes break down into data in, do something, data out, right? But this is a bit more advanced than that. What we do in phase one of the team data science is we try to understand the problem we're trying to solve. That's a bit different than in some software development projects, because for data science, one algorithm or set of algorithms will make one prediction or classification. You can't take a linear regression that's made for something and then just throw it at something else. You have to change things. And so we have to really define our business understanding of the problem. The next thing we need to do is talk about data acquisition and understanding. We need to explore our data, find out where it is. And then in phase three, we do what most people think we do, which is to create the model. And at the very end, we deploy that model. Now, in a data science project, you often need to retrain your model. So these things wrap back around on each other. Now, why do I cover the team data science process when we're talking about security? And the reason why is there's more to it than just layering in some security constructs. We think about all of those phases that you just had, and then we think about the different things that are involved. There's programming, there's the statistics, there's the data itself. So we start way back with the data, and we look at something called data security. Now, data security is fairly platform dependent. When you think about a relational database system, an RDBMS, like SQL Server, Oracle, platforms like that, they have quite a few surface structures that they deal with. The security onion that we all know about that they go through involves the physical environment, making sure nobody can get in the server closet and so on. The operating system, it's got to be patched, whether it's Linux or Windows or Mac or whatever you've got. The engine surface, so SQL Server engine, Oracle engine, has specific hardening capabilities within it. And then there's the data objects themselves. Tables and views and so on have a very granular level of permissions. those permissions usually vector on two things. How can I access that particular object? And then how do I authenticate to be able to use the object? So can I get to the object, and then can I use what's in it? It's very granular. On top of this, we have sort of our forensic world where we need to be able to audit who has done what, sometimes up to and including, did they even just look at it? Did they even try to look at it? And so on. And then finally, we have encryption. And encryption is a preventative measure. And we have encryption at rest, and we have encryption on the wire, and we have encryption in memory, and so on. Lots of different ways we need to think about on the relational database system. So the relational database system security is actually quite mature. We've seen this for many, many years, since the 70s, and it's been kind of a solved problem. Nothing's a solved problem in computing science and security, but it's very close. Enter the world of non-relational data. Now we're thinking about things like Hadoop and MongoDB and these kinds of things. When we think about non-relational data, often you've got a smaller surface that you deal with. And by the way, this is by platform, which is what makes it complicated. You still have your physical environment. You don't want anybody in your server rack that doesn't need to be there. And you still have an operating system. At some point, there's a computer and it needs to be secured. But now we start thinking about our remote procedure calls, APIs, and so on, and the ports that they work across. That becomes a little more paramount. This becomes part of the access to the system, not necessarily the authentication, but it might be. The authentication is often handled in these systems, like Hadoop and so on, with ACLs, access control lists at the operating system level. Because at the end of the day, you're hitting a file. And the engine may need ACLs, and the users may need ACLs, and it may be a combination of those things. And depending on the operating system, maybe you're in groups and so on that you need to think about. Well, these systems also have encryption. Some of them have encryption artifacts built within the platform, and others rely on the operating system's encryption. So we've got a different surface area here. And then, of course, we don't always have auditing inside an operating system, but we often have logging. We can often tell who's done what, but not necessarily who's tried to do what and their intent and so on. Now, when I talked about the data security, and we think back to that team data science process, we think about the idea that you've got both those kinds of data coming into the system. So literally in step one, we're automatically presented with some challenges. Now, not only that, this is a software program, and some data scientists have been trained as software developers and others have not. And so sometimes we're more worried about, does it work? More so than is it secure? And sometimes you don't know what you don't know. And so there is the trustworthy computing security development lifecycle, big long term there, SDLC, that you think about. And these are the standard phases. And if you've not seen these, or if you're not familiar with them and you are a data scientist, there's a lot going on here. So when you do a software development project, the first thing you're supposed to do is have an education and awareness session. That's not at the beginning of time, that's per project. We'll say, hey, we're going to be using MongoDB in this, and we're going to be using some Hadoop, and we're going to be using SQL Server. So let me give you a quick 411 on what those things are. And so that actually is the start of it. Then you have your project inception, and you design, and you have your risk assessments and so on. These become part of a very complicated process within software development, and we still have to consider that we're not done. Data science processes have a different sort of cycle threat analysis that we have to think about. They not only involve the data and the software security, but there's usually a pipeline, something we're using to move the data through, and there's platforms involved. And interestingly enough, as I showed you in the team data science process, there's data engineers, perhaps multiple data scientists, perhaps multiple developers. All of them have a different picture and so on of how these things work. And there's some fairly unique threats inside an AI project. One is this idea of resilience and discretion, and I'm going to give you some links for that because we don't have time to go over that today. There's also authentication, the separation of duties, and a big one here is input validation. Well, what does input validation have to do with anything? Well, At every phase of this pipeline, you can imagine that there's actually an input signal that's coming in. Andrew's going to show you some examples writ large at these things, so you'll see some concrete around this in just a moment. I'll point out here a black swan event detection. What's a black swan? Well, in mythology, there's the idea that the swan introduces its young into a series of these other swans, and this one is raised as your own, and you don't realize, hey, that's not my swan. This kind of thing can happen. Let's take a practical example here. Let's assume I've got a self-driving car, and I want to train it to navigate the roads. One of those things would be to navigate road signs and so on. Maybe stop signs would be a good example. Now, as we think about those stop signs, we have to have training data that shows the signs from different angles, perhaps even different formats. If the car is being driven internationally, they would need to see all the stop signs. Now, imagine I don't try to attack the system at all, but I simply poison the pictures of stop signs with other signs. And so now the training algorithm is presented false data, a black swan, to train on. And when that happens, my self-driving car just goes right through a stoplight because it doesn't recognize the stoplight. The same goes for medical equipment and military equipment and so on. The other thing that's important is that each system needs to create an innate forensic capability. Every step along the way, especially in data science, you can't always tell sort of what's happening there. There's not always this idea of being able to define what's going on. Certain deep learning models are very black box, and I don't know what's happening. If somebody were able to change the hyperparameters in some way, I could dramatically affect the outcome of the prediction. And as I pointed out, some of those predictions can be a little scary. Let's take a practical example here. So I'm using the SQL Server Big Data Cluster platform. This is a platform that's wrapped in Kubernetes. It's got containers in it. Each container does things. There's a primary instance of SQL Server that is just SQL Server. And then there's a scale-out SQL Server that it talks to called the compute pool or series of SQL servers. And there's a scale-out series of SQL servers with round-robin databases. So that provides scaled relational data. And then it's got a subsystem in it for Spark, HDFS, and more SQL servers to talk to non-relational data. And all of these things can talk together. At the end of the day, when the machine learning algorithm is trained or the Flask app is complete or whatever it happens to be, it can be deployed into another container, and this is called the application pool. So these pools provide input areas. And in large part, we think about this system pretty much in just one way. The user, the bad user, is trying to get in, and perhaps they're trying to come over the tabular data stream or TDS input, which is the standard input for SQL Server. So they're trying to use attack vectors against SQL Server. Or perhaps they're going to go after the Spark API. Or maybe you didn't tighten up the Flask application properly. You're using an outdated version of Python or something like that. And so you have in the application pool. So we think a lot about the attack surfaces here. But in fact, there are far more. Kubernetes itself was not really designed with security in mind at first. It's been dramatically improved and does have that, but it's something you need to think about and you need to harden. You also need to harden the controller that this thing uses, the SQL Server instance individually, each one of the SQL Server instances, the Spark instance, the HDFS, and your app pool. It becomes quite complicated to do sort of a threat matrix on this. We do have a tool to threat model an application. We have something called the Microsoft Threat Modeling Tool. Here's an example I was working on recently. This is a system that takes an input from a camera and can help the doctor determine, actually takes it from an x-ray, and can help a doctor determine, is this something I should set or look at more closely? And you can see, you simply drag out items and you describe them in their details. This is a free tool. You can find others out there. I happen to like this one. It works pretty well. And then what I can do is once I've told the tool a lot about what this thing does, the sensor, does it have a database? Does it have an API? All those sorts of things. Then I can click do an assessment, and you'll see those assessments down in the bottom. Here's one. I've clicked on the sensor itself, and there's one called title. Well, hold on. I think I can zoom in. There we go. Tampering with the image detector configuration. And perhaps I didn't realize that that sensor, that little camera that I've got that reads the picture, have I read up on the hardware and the firmware? Have I updated the firmware? That's something I didn't think about. So I need to mitigate that, and I need to give it a priority. And so I'll put down in there, and you can even see, consider using code signing or cryptographic signatures on configuration files to mitigate the risk. Well, that's interesting. So for instance, I could do a simple CRC on the file itself, even if it's a text file, to see if somebody's tickled that configuration since the last time I used it. Now, I guess the point here is to model your application successfully. It requires you to probably use a process and a platform. I happen to use the team data science process, and I use the threat modeling tool here, along with the secure development lifecycle. Now, I've got, as I mentioned, let me pop over here. I actually have got these things here. I don't know if I can get to them all, but there's the machine learning operations. Here's the secure development lifecycle process from the US government, from the certification of the US government. And then there's the threat modeling tool that explains sort of how do you use that. So let's pop back over to our slideware here. And again, you've got all these links available to you, so you can do that. Well, we've gone really quick here. It started just a tad late, but we've caught back up, I think. And so I want to hand it over to my friend Andrew. He's a principal security program manager here at Microsoft, has been working in these environments a long time. And he and I worked together on this deck for a while. So Andrew, if you want to go ahead and share your screen, when you do that, you'll steal from me. And then I'll stop my video and I'll go on mute, but I'll join us back after Andrew's done and come back doing that. Okay, thanks, Andrew.
All right, thanks very much, Buck. I appreciate it. Let's see here. Get this. All right. So just to actually, before we even level set, just a little bit about me. I am a security engineer by trade. I work across Microsoft solving long-tail security engineering issues that maybe not one particular organization in the company owns completely. And I do a lot of security research in different evolving fields to figure out what's the next thing that is going to bite Microsoft and our customers in the next 2, 3, 5 years? And what do we need to do in terms of getting ahead of that problem? And I started hacking machine learning models about 2 or 3 years ago and working with data scientists and security engineers and researchers at Microsoft to put together a series of research publications that I'm going to share with you today, and some of the more salient points from it, basically conveying a net new threat landscape in machine learning, as well as how to incorporate these threats into your threat modeling process, like Buck just talked about, and how to mitigate these threats, as well as where we're going as a company and as an industry in dealing with these issues. So and Buck hit on a couple of these things earlier, but I just want to say I'm not going to be getting into how to use artificial intelligence for adversary detection. There's a lot of great threat intel work being done with machine learning, but I'm really just focused on how do we protect our products and services that are either built with AI and ML at their core or bolting it on as a dependency. So why should you care about this? Why is this a big deal? Why is this one of the next frontiers in InfoSec? Well, here's a real life example that has, there were some mundane things at the beginning that led into some very catastrophic issues. So basically we had an oil company who was scraping oil futures data off of different trading websites and aggregating that locally. So all of this data was scraped over a secure channel and then ingested locally, and then it was fed to machine learning models. So these machine learning models were used to do high consequence AI guided decision making. So basically informing people, hey, we're going to either take a long position or a short position in the oil futures market, or we're going to bid for oil drilling rights in this particular location. So what we're going to see here is an example of a data poisoning attack specific to machine learning that doesn't, there's not like a standard mitigation for this kind of thing yet. This is the input validation equivalent specific to machine learning. And the reason this is important is because it demonstrates a gross over-reliance on untrusted, uncurated, public access training data. You don't have mechanisms today, generally speaking, that can do input validation and tamper detection on training data in an automated way that can alert you to these threats. Just like these data providers here on the left-hand side of the screen, a lot of them had no awareness that they were even compromised. So what happens here is one of these data providers, they get their data feeds compromised, and then anybody scraping that content or ingesting that content in any way, that contamination spreads locally to those customers, and nobody is the wiser. So what happens is, what happens when you get garbage in, you get garbage out. So this maliciously compromised training data was then ingested by the machine learning models to make garbage machine learning decisions. And then there's no way to, in an automated way, detect this. The only reason they knew something was going wrong is because they were consistently on the wrong side of their trades, and they were drilling for oil in the wrong locations. So these kinds of issues typically manifest themselves today in very big, high publicity ways. And this is just one of a class of new threats that we'll talk about today. We've published a machine learning threat taxonomy, as well as a bunch of threat modeling guidance and bug triage guidance. I'll talk about more about that in a sec, and also connect you with that content at the end. The idea here is that you can take this content that's public now and give it to your security engineers and your data scientists, and incorporate this, what we've learned, into your security design review process, and start addressing these threats today. Why is this ramping up in such a big way? Well, let's take a look at the lessons that we've learned as an industry from the world of cryptography. All of your big cryptographic vulns over the past decade and a half started off as proof of concept research contrivances. Basically, a variety of research papers were published with POCs to make a point. And then the volume of research just took off. And then there was a inflection point that happened in that field. And there was a pivot from the proof of concept contrivances into weaponized exploitation. We see that with different crypto algorithms like MD5, SHA-1. We saw it with security protocols like SSL-v3. We'll see it with TLS 1.0. And we're going to see it at a much more aggressive rate. In fact, we already are with adversarial machine learning. These are just a couple of examples here. The other thing is that it's getting easier and easier to pull these attacks off. It's almost like the effectiveness of the models is going backwards in a way, because what we need are robust automated detections and mitigations. You need to be able to detect adversarial ML attacks and revert from the damage they do, much like you would revert a system that was contaminated by a virus. You need to be able to detect the virus, quarantine it, remove it from the system, and revert to a last known good state. One thing I want to talk about here is kind of our tie-in to ethics at Microsoft in AI and machine learning. a lot of the stuff you see on the news is going to be related to, racist search results or self-driving cars blowing through stop signs. We are approaching most, if not all, of these issues as higher order impacts of unmitigated security threats. And because every single one of those, if you drill down deep enough, there is some type of security threat that more often than not is the culprit in these kinds of things. This is a quick example of an image fuzzer I wrote a couple of years ago. Basically, it used to be that you would have to do a lot of serious image manipulation to fool an image classifier, a neural net-based image classifier. And then with the fuzzer I wrote, we were able to manipulate just parts of an image to be able to have a lot of impact. Here, it's even more pronounced because this just looks like an Instagram filter. So these sepia filters that are applied to these images, it doesn't look like there's, contamination. It just looks like something, a normal image you would see online. But it's enough to cause a significant adverse behavior in a machine learning model. So, for example, the sepia filter is applied to the stop sign, takes the confidence rating of the classification of the stop sign down from 96% to 67%. I don't know about you, but I don't want to be in a self-driving car or walking in front of one that in bad ambient lighting only has 67% accuracy classifying stop signs. On the right, you see a stealth fighter with 93% confidence in the classification. And then all of a sudden, just a filter that's even less obvious here, it's now recognized as a sundial with high confidence. And these are just, these are a lot of the examples of, proof of concept research stuff. And then the prior example I gave of the data poisoning threat, that is the real life pivot to weaponized exploitation. Here, this threat is called adversarial perturbation or model evasion, where you're essentially tainting an input or crafting an input in a way that fools a model into taking an action that it wasn't designed to take, or returning a result, in this case an image classification, that is incorrect. So getting back to how we're approaching this as an industry, Microsoft, in partnership with the Berkman Klein Center at Harvard, published in December a adversarial ML threat taxonomy covering all of the net new threats in this space from a intentional adversary-driven failure mode perspective, as well as unintentional failure modes related to like industrial failures related to reinforcement learning, for example. But we're really focused on the adversary-driven threats here because this is the big uptick that we're seeing. So in addition to the taxonomy that we published, we also released a detailed document on how do you threat model all of these net new threats in this space? How do you incorporate this into your existing security review process? And in conjunction with that, there's a third piece of guidance that we've published, which is how do we actually triage all of this content? So if we have a adversarial machine learning attack against one of our services, how do we actually deal with it? How do we compare it to traditional security vulnerabilities and take the right action? So here's just a couple of examples of the, these are just some examples of the content from the taxonomy. So this is essentially our top 10. Data poisoning, which I showed the example of the oil company at the beginning. Model stealing, this is essentially where a model is queried exhaustively in a way that you can essentially reverse it and acquire a carbon copy of the model and the IP. there's a variety of threats here, both at the at model deployment time, like when it's running as part of a service, as well as when the model is actually being developed in a training time. What I want to get into here is the threat modeling content. So finding security engineers with data science expertise or data scientists with security engineering backgrounds, that's like hunting for platinum unicorns. So we published this threat modeling document, Threat Modeling AI ML Systems and Dependencies, as a way to bring security engineers and data scientists to the table so they can have this common conversation and get this holistic threat landscape, build it into their security review process, and then take the appropriate action. So I want to jump out of the deck for just a second here and show you, this is just a little bit of the threat modeling content. So we start off with simply, what are the new questions we need to start asking in a security review for AI and ML based services? Then there's a lot of content here. Really, this is made for your data scientists and security engineers. So the first couple of pages are really, how do we incorporate this into our threat modeling practices? The rest of the content is, okay, we've identified specific threats that we need to mitigate now. What are the latest, what's the latest research available for each of these threats in terms of detections and mitigations? Well, the problem here really is that mitigations, broadly speaking, don't exist in a automated way. A lot of the, which is why we had to publish all of this content. A lot of the mitigations are frankly bespoke at the moment. We're working on dealing with this and addressing it in our future products. But for right now, we felt it was important to connect people with the latest research in this space so that, you know, if they need to take early action on a particular type of threat mitigation, then they can do so. So kind of rounding out all of this is, all right, we've got these threats. How do we do the apples and oranges comparison with the world of traditional vulns? How do we compare a model inversion attack or data poisoning attack to a wormable remote elevation of privilege attack, for example? So we published another document called AI ML Pivots to the SDL Bug Bar. Again, building on the threat modeling guidance and the ML threat taxonomy that we published in order to give people triage guidance in this particular space. So we are not only connecting people back to the threat modeling guidance and the taxonomy in the bug bar, but we're also giving you examples of the traditional threats that they're equivalent to, as well as business impact cases for these particular new threats. So all of this content is on docs.microsoft.com/security/engineering. All right, last slide, kind of wrapping things up where we're headed as a company. Where we need to be as a company and as an industry with all of this is really transparent, on by default, platform inherited threat mitigations, completely automated. You're not going to catch data poisoning attacks or model inversion attacks or model stealing attacks manually. You know, we have to create new sources of logging and new detection algorithms to be able to look for feature relevant statistical drift in training data to be able to spot data poisoning. So we're working on developing new threat mitigations to deal with this, and then exposing that as protections that you get by using our platforms. So like, look at Visual Studio today. When you compile code in Visual Studio, you get a ton of transparent, under the hood, platform inherited security threat mitigations. You don't have to be a security engineer to use it. You just get all that goodness for free. And that's where we're going with this for adversarial ML attacks as well. So right now we're doing a lot of tooling, proof of concept work within Microsoft and importing that into our engineering groups. We're driving the guidance that we've published. We've made it a part of the security development lifecycle. We're driving that throughout the company as well. Our security teams are piloting all of this content as part of their security reviews. Our data scientists and researchers are doing the same. And over time, this leads to new products that are available externally and shaping of industry standards as well. But we have to be careful here at the same time that we don't want to be overly prescriptive in what we do as within Microsoft on dealing with these threats. We always want to have automation to back up any kind of security requirements that we drive onto our teams. So here we're actually in the as we're developing these threat mitigations, we're going to eventually pivot from this guidance to making it more of a mandatory thing throughout Microsoft, backed by this automation, and then our customers will be able to benefit from it too. And let's see here. There's our last resources slide. So that's all I've got. Buck, you have anything that you'd like to add here?
I feel like I've been through a car wash here, and we've gone
really crash
through a lot of material at one time, and I know the audience is probably feeling the same. Hey, listen, I did see a question there. Hey, can we get the materials? They're all right here. Ron's also going to provide you some information after this event and so on. We really appreciate him having us on today. We're very passionate about security and AI, and if you'll just go out and do a quick web search, you'll find that there's not much about AI security. It's mostly about using AI for security. So we're really glad that we're able to talk about this. We feel Microsoft's at the forefront of this. Again, the presentations are there. You'll see down at the bottom a link to bring down the PowerPoint. If you're not familiar with GitHub, by the way, you'll just click the download button and you can pull it once you get to that link. If you go to the location, it will not show a PowerPoint file. You'll want to open the PowerPoint file and look in the notes view. And in the notes, we've put all of those links that you saw, all those free tools and more. At this point, I think we can turn it back over to Ron. Ron, any last minute instructions for us, sir?
I thought that was fantastic. Again, what we're trying to do here at AngelBee is give a wealth of information on related topics, condense it without being rushed, and then we're absolutely able to set up follow-up conversations with everyone, with Buck, Andrew, and other subject matter experts. Buck, maybe you can just comment on Ton from Schlumberger, the huge oil company, who was asking if there's a need for version controlling massive data sets. I think that might be an interesting topic that you could just briefly discuss before we switch and cover topics around IoT security.
Yeah, absolutely. And thanks for that question. I did respond back to that in text, but I'm glad we've got a chance to verbally address that as well. You do sort of need to think about versioning your source data. I don't know. It's difficult to it's difficult to version, like if you've got thousands of files coming in from all over, what do? Well, you can, within your ingestion phase, work with your data engineer to at least validate the file. And you should do at least that. Like, are those entries real? And you could do, this is a bit of overkill, but depending on what you're doing, it might be useful. You might want to take a look at some light anomaly detection algorithms across those, just to see if there's any unusual outliers. Now, the second phase inside the team data science process is the idea of ingesting and examining your data. That examination should include at least the big 5 stats and all those kinds of things. Look for deviations in the data and outliers in the data, figure out whether you're going to trim those and so on. What I would say is that rather than versioning the source data, I would figure out, do I trust the source data? And I'd give it a score. We do that here. Do we trust this particular source? Secondly, did I have to secure the source to begin with? Is it public data and it's on Wikipedia? you could still use it, but is that trustworthy data? Probably not. You'll want something you can verify. Treat yourself like a newspaper reporter and verify your sources to be sure, and do that examination and that upfront work to make sure. If you do find something that's anomalous during that second phase in the team data science process, if you do find that anomalous data, check the source and then flag that so you can have your data engineer go back and say, hey, go check into this. They may have poison data and not even know it.